Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on tNavigator for reservoir simulation. And today's topic, I think will be very interesting. I think it will be very useful, especially if you're handling water injection, water flood, or CO2 injection, CO2 storage operation. Okay, so to learn about this case, we are going to use a sample case from tNavigator, and I'm going to show you the interface, all right, the software itself, as well as the script. Okay, so currently we are opening a tracer case from tNavigator. We are looking at 2D map, all right, two-dimensional map, especially the pressure. Okay, and we can go to the 3D model and we find in the initial time 2 wells. But if you move the like this one time slider, in this reservoir we have many wells and we have several water injectors there. All right, and we will put tracer on some injectors so that we later on we can trace where the water from each of this injector goes to. All right, where the water goes to. All right, so this is very important, especially if you want to know the breakthrough time, if you want to assess the sweep efficiency, either vertical sweep efficiency or lateral sweep efficiency. Later on, you can also predict the volumetric sweep efficiency, right? And again, as I said before, you can use this for water injection, gas injection, or even CO2 injection, all right? So yeah, you can use it for black oil operation or compositional modeling. Okay. All right. So I think from here, there is nothing special for the grid properties, right? So let's go directly to here. Right. Okay. So yeah, we open with run spec and this is the title tracer from wells. By the way, this is very important. I think this is the main thing. Okay. Nothing special here. And this is the first keyword that's very important, tracer. Okay, so here, by the way, if you want to know about this case better, I recommend you to open also the tNavigator manual. Okay, so this keyword means that yes, you will use tracer and you will have two tracers, this tracer and this tracer. Okay, and you will have 22 tracers for this one and 20 tracers for that one. Okay, basically, yeah, the number here, I think it's not very important because yeah, usually in our operation, we only use maybe 3 types of tracer or 5, right? But of course, you can adjust this number. You can use your own number based on your, based on your case. Okay. Basically, I just use maybe 10 tracers here. So yeah, it's just the template. So we can be more flexible if I want to put more tracers later on. Okay, so you put tracers there. In this sample, they put the tracer keyword after oil, which means you will use oil, and water, which means there will be water, and you put tracers there. Okay, still in the initial part. So that's the first thing. That's the first keyword. And then yeah, implicit, no echo, the dimension here, 40 for the X direction, 65 for the Y direction, and just one layer in Z direction. Okay, so the total number of grids, you can just multiply 40 multiplied by 65 and 1, and you can get that number here. So we have 2,600 grids, okay, which is yeah, not too many. easily manageable. Rect dims, tap dims, equal dims, well dims, nothing so special there. And now we are entering a grid section. So grid init for initialization and include. So for the grid, I will use the grid from this file, test 06 underscore tracer underscore grid underscore inc or include. So the second keyword that's relevant for this streamline calculation, you put that keyword under the props, right? So here under the props, we have stone one, okay? And then input the or include the PVT, include the relative permeability. And this is the second keyword, tracer, which means that you will describe the tracers that you will use.